now we're moving into causal analysis. You've gotten all the basics, well, most of the basics down. It's been a long slog, I know. Many hours spent on the problem sets, but now we can start to apply what you've learned and do so in a variety of ways. First, we'll start out with ways in which regression can be used for causal analysis. You know, it's obvious that if you've got a random assignment experiment, you can use regression analysis to come up with proper estimates of the impacts as well as the standard errors. But now we're getting into a couple of less obvious kinds of quasi-experimental analyses. One is regression discontinuity. I set that up in the lecture last week. That we'll talk about today. And then next week is fixed effects, difference in difference kind of approaches to causal analysis. Both are very widely used in some education research and are unknown to a lot of other education researchers. So let's get to it. And before we dive into regression discontinuity, I wanted to set up a distinction that pops up recurrently, both in experimental, straight up experimental analysis, as well as these quasi-experimental kind of techniques. So one big distinction is between the impact of the offer of a program to a population of interest, and the other part of that, you want to know the impact of the offer, but you'd also like to know the impact of participating in the program, right? Typically, when you go out with a program, offer it to people, take-up is not universal. Sometimes take-up is far from universal. There was a big housing voucher program called Moving to Opportunity that provided very generous housing subsidies to families who would move from public housing projects to low-income neighborhoods. And only about 40% of the people offered that chance were able to take it up. They had 6 months to find a place. You know, it was very, it wasn't such an easy thing to do, but 40%. In the Head Start impact analysis, parents whose kids were on wait lists to get into Head Start were randomly assigned to either get a slot or not get a slot, not be offered a slot. And of those who were offered a slot, I think 20% didn't take it up. And some of the people who weren't offered the slot in that preschool program, Head Start program, found a Head Start program somewhere else. All right, so if you think about the problem, you've got kids, you want to know what the impact of the Head Start program is. The impact of the offer of the Head Start program is very straightforward, right? You had all the kids on the wait list being offered, and everybody's being followed. The ones who were on the wait list and offered a slot, and the ones who were on the wait list not offered the slot, everyone's followed. Their socio-emotional behaviors, their academic achievement levels, all of that was measured a year later. So some of the kids who were in Head Start were measured at the end of the program, and others were measured at the same time, but they had not been in the Head Start program, right? So the impact of the offer is very straightforward, but what about the impact of the program itself, right? Not everyone who was given a chance to participate participated, and some of the people who weren't offered ended up participating anyway. So, moreover, I mean, that's a problem in and of itself. But moreover, people who end up with an offer and participating are likely to be different from the people who got the offer and decided not to participate, right? That could be a highly selective kind of process. So there's a lot of selection bias there. But there has been developed a way of estimating an impact on participating in the program in the context of a random assignment program. And in contrast to the ITT, intent to treat, right? If you if you approach a group and give them all an offer, you're intending to treat all of them. Not all of them take it up, but that's the intention. So this impact of the offer is called intent to treat, ITT. And then the impact of participating in the program has many names. One is the one I'm most familiar with is the treatment on the treated, TOT. All that means is, the people who were quote unquote treated are the ones who participated in the program. So you wanted to know the impact of the program on the people who took up the program. That's all TOT means. But all these other names mean the same thing. Impact on the treated. That's obviously, the same thing. What is the impact on the treated, IOT? There's a lot of people in the economics literature will talk about local average treatment effects. Late, we're talking about the same thing, right? These are people who actually participate in the program. And it's an average in the sense that all impacts are averages comparing the control group to the treatment group. And this is sometimes the same thing as sometimes called the compliance average causal effect. Compliance means participating in the program. And then it's an average causal effect, CACE. So all these things mean exactly the same thing. And the economics literature tends to talk about LATE, L-A-T-E, the local average treatment effect. The more conventional psychological and education literature will talk about TOT or maybe IOT. But as I say, they all mean the same thing. They're just different phrases for expressing the same thing. And what we're going to show in a minute is miraculously, this should be a very, very difficult thing to estimate because of all the selection involved and who takes up the program versus who doesn't. But I'll show miraculously that this, in all of its names, LATE, TOT, and so forth, turns out to be just the intent to treat divided by the participation rate. Okay, we'll see why that's true, but you could be forgiven for thinking that getting an impact on people who participate in the program in light of a lot of selection bias is a more difficult task than just dividing the intent to treat estimate by the participation rate. So I don't expect any of you to think, oh yeah, that follows directly from the ITT. Okay, so far so good. It's just terminology. So let's, if I can, get this out of the way, erase it. And we can talk about how to estimate. First, intent to treat. Well, we've already talked about this, right? Remember the example of the treatment group and control groups that each had 100, and the treatment group had scores of 110, control group scores of 100 on some measure. And to estimate that, we either did a t-test or if there are control variables, or even if there aren't, we could do some regression where the outcome is some function of t, which is a 1, 0 offered the treatment, offered the program. That equals 1, not offered is 0. And then maybe we've got control variables. All right, that's all we did before, and that's very straightforward. Everybody still with me? This gives B1 is the ITT, intent to treat, impact of the offer of the program T on the whole population of interest. Everybody still with me here? Okay, so let's talk about how the TOT can be as simply expressed as ITT divided by participation rate. Let's use an example. Let's suppose we've got some sort of behavioral program offered to 100 individuals with 100 other individuals serving as controls. And the outcome of interest is crime, let's say number of arrests. All right, so it's some sort of, I don't know, cognitive behavioral therapy program for teenagers. It's rolled out and offered to 100 of them. 100 are serving as controls. And not all the 100 are actually taking up the program. So let's make an assumption about that. Suppose take up, in other words, participation rate, in the program is 50%. All right, so we've got this program. We try to talk 100 people into participating in the program. And in the end, only half of them participate in enough of the sessions of the program for them to be considered to have taken up or participated in the program. Now, suppose we track everyone and find uh, 75 arrests in the treatment group, the total treatment group, and 100 arrests in the control group. So, you know, what I mean by in the treatment group is everyone offered the program. Okay, 75 and 25. Or I'm sorry, 75 and 100. So if you think about what we have here, number of arrests, treatment group, control group, $100, $200, $300. All right, we've got treatment group with 75. All right, so this, I'm sorry. I was trying to find these. Suppose this, I'm sorry, suppose this is 150 and this is 200. Okay, sorry. So we've got 100 individuals in the treatment group. Some of them take up the program and some of them not. And the total number of arrests in the treatment group is 150. We've got 200 individuals in the control group. And on average, everyone commits gets arrested twice. So there are 200 total arrests in the control group. So we've got 150 here total, and then 200 here. So first question, what is the ITT?
Wait, I just wanted to clarify. So the total number of students students in the control group is 200, and now 200 is in the treatment group.
No, 100 in each group. This is the number of arrests.
Okay, so there might have been multiple arrests per person.
Exactly, and there were. Okay. There had to be down here, right? And well, there had to be up here too, right? We had more arrests than people, right? So on average, the controls were getting arrested twice, right? On average. And here, the 100 people were generating 150 arrests. Okay, so what's the ITT? $50 per how many individuals?
Per 100 or 200? 100. Right? Yeah.
Yeah, 100, right? So we've got of the 100 who were offered the program, well, of the 100 at each group, the difference in arrests was 50. So it's 50 per 100. And that would be if we regressed arrest on A plus B1 treatment. And this was the offer equals 1. No offer equals 0. We'd get a coefficient of 50. Minus 50, actually, right? It's a 50 fewer arrests. All right, that's the easy part. What about the impact of participating in the program?
Excuse me. So
Only
is the ITT negative 50 or 50?
It's negative 50. The
Okay.
number of arrests is 50 fewer in the treatment group relative to the control group.
Okay, thank you.
All right, anybody? I said it was magical, but in fact, it's not magical. Anyone see a way of figuring out what the impact of the program is for the people who took up the program? Only half the people took it up, right? Of the 100 offered the program, only 50 took it up. We've got 150 arrests altogether for the people who took it up and didn't take it up in the treatment group. How do we figure? How do we get a comparison group in the control group to figure out what the impact of the treatment on the treated is?
We need to, I think, add an interaction with participation and treatment, something like that, to know how many. We have to know how many people how many arrests was from the people who took it up, right? We can't tell really, but not knowing how many arrests were from those people.
So there could be a lot of selection going on into participating in the program, right? And that makes a simple kind of interaction not work because you're not controlling for that selection process. Anybody else want to give it a try?
Greg, is the participation rate based on just the treatment group, or do we include like treatment and control group?
I'm sorry. So we're assuming that there's no take up in the control group. You know, I started out with this Head Start example where some of the parents who weren't offered the Head Start slot found a Head Start somewhere else. Here we're assuming that that's not the case here. There was no other way that the control group kids could get into the program. All right. So all you know is, you know, of the 100 that did get the offer, 50 participated. Of the ones who didn't get into the program, 0 participated.
Then wouldn't we just divide negative 50 divided by 0.5?
Well, that's that's the solution, the magical solution. But I want I'm trying to figure out how to get to that ITT divided by the participation rate. So a hint, you've got more information than what we put on the board. You've got, you know, arrests for everybody, everyone in the treatment group, everyone in the control group. You know exactly how many arrests all 200 people have. Anybody want to give it a try? So the key bit of information that you can bring to bear for the treatment group individuals who didn't participate number of arrests are, and we can make up some number here, right? You got records on everybody. So you can look, you can take this group of people who were offered the program. Half of them didn't participate, 150 crimes altogether for all 100, but you know who didn't participate and who did. So you can see what the arrest rate is for the people who didn't participate. Okay, suppose that's 125. So this is just made up, just as the other numbers are made up. But we've got 125 arrests that we've recorded for the people who were offered a chance to be in the program and didn't participate. All right, anybody see what we can do here? In the control group, given random assignment, uh, 50 of the 100 wouldn't have participated. And we would expect them to commit how many crimes, how many arrests for the people who would have participated or would not have participated had they had a chance to participate. It's random assignment. We've got two balanced groups.
100 crimes.
How do you get 100?
So if 50 of the 100, this is assuming that it's distributed, that the number of crimes are distributed equally. 50 of the 100
Equally between
people in the control group. Sorry, yeah, in the control group. This is assuming that because we don't really know the number of like how many people committed which crime. Our assumption is that if we have half of the control group, then that would equal half of the number of crimes committed, which is 100.
Well, but in the treatment group, that obviously wasn't the case, right? There were 100 people in the treatment group. Half the people didn't participate, and there were 150 arrests altogether, right? So it's not going to be evenly divided up. I mean, we already know that 125 of the arrests are for the people who didn't participate. That's what we are assuming here, right? For the treatment group, individuals who didn't participate, we're assuming the arrest number is 125. So of the 150 total arrests, 125 we can observe in the treatment group are the people who didn't participate. So there's only 25 left over. So it's not balanced at all between the treatment and control group, or between the people who participated and people who didn't participate. So anybody else filling in this this blank? I'm saying we know in the treatment group, because we can observe who participated and who didn't, that the people who didn't participate were arrested 125 times. So if we've got balanced groups, we would expect that 50% of the control group wouldn't have participated if they had a chance. And we would expect them to be just like the people who didn't participate in the treatment group, because it's random assignment, right? So they would be expected to commit 125 crimes, just like people who didn't participate in the treatment group committed 125 crimes. All right, I'm not seeing a lot of. Maybe you're muted, but I don't hear any. Oh, I see it now.
For me, the question is itself a bit confusing. I don't understand the scenario that you're asking us.
Well, let me just keep going. So if of the treatment group, we have 150 total crimes, and 125 we observed to be by non-participants. And then 25 by participants. $25 by participants, 125 by non-participants. The logic here is we've got random assignment, we've got equally balanced groups. So of the non-participants or the would-be non-participants, had we offered everyone in the control group a chance to participate, we would expect half of them not to, just like the treatment group, and we would expect them to commit 125 crimes, just like the treatment group. These are would-be non-participants. They didn't have a chance to reveal themselves to be non-participants. But given the treatment balance, random assignment, they ought to be matched in the control group to the treatment group.
I have a question.
Yeah.
I don't understand why they would be matched, because if 125 participants chose not to participate, then I would think that there's something that they have in common that would kind of hurt your random assignment, which makes the two groups not very comparable.
Okay, this 125 is crimes, right? It's not people. We've got n equals 100, n equals 100, right? We're talking about number of crimes committed. That's kind of a minor point. But for the treatment group, we're following everyone. We know who was arrested, and we also know who participated in the program, right? So maybe is that part of the hang up? That's just looking at data and seeing, of the 50 people who didn't participate, for the 50 treatment group individuals who didn't participate, their arrests totaled 125.
So it is part of the data, what you're saying, but I think conceptually what's hard to line around is equating participation in Head Start, which is
No. We're done with Head Start.
Okay, well, even
this is all this behavior program offered to teenagers.
I understand. Even that concept alone and equating it the way you are is a tough concept to put your head around. But I don't want to get diverse too far because you're saying that that's a minor point. But in your examples, when you're trying to think this thing through, it does make it a little bit more difficult.
Okay, well, we could have gone on with Head Start, and it's just easier if you've got something you can count, like arrests. That's all I just went for something that was going to be easier to understand.
Yeah, I think you're missing the point. I don't want to layman too much on this because I know we have to test and we want to move on with class, but even equating children the way you are with the rest is tough to wrap your mind around. That's all I'm saying.
You mean to equate the treatment group kids with the control group kids?
I don't want to spend too much time on that because I think I've been as clear as I can. Even that concept that you're talking about there, we do know kids go to jail later on and things like that. But how it's a very tough tough concept that that you're talking about. You know, but I do want to just focus on the data and focus on the equations here. But when you're asking us to use background knowledge, other things to kind of make these connections and things like that, I'm having to, in my own head, like kind of change some of the terms that you're using just to make sense of it, you know?
Well, I mean, it's certainly the case that all of this is playing out in a context of neighborhoods the kids live in, right? Of police actions that the kids are exposed to and all of that. You know, the fact, again, that we are randomly assigning individuals means whatever complicated kind of contextual conditions that apply to the kids chosen for the treatment group, on average, apply to the control group as well, because we just drew them at random, right? Both groups are balanced in terms of where they live and what the neighborhood conditions are and police conditions and things like that. So it's not trying to understand who gets arrested at all. It's just counting up the number of arrests that happen and trying to relate differences in arrests between the treatment group and control group to get a causal impact of this behavior program.
No,
right? And the behavior. Go ahead.
I get it.
Okay. So Tiffany, I didn't do justice to the second half of your point. You want to try again with that?
No, I think I'm good, actually. I think I'm completely good now.
Well, then what's the TOT? We've got 125 arrests among would-be non-participants and 75, right? The difference up to 200 among would-be participants. All right, so we know this from the treatment group. Because of random assignment, we know it would have been the case in the control group had the control group been offered the program. So what's left is this 75 arrests among the people who would have participated in the program had they had a chance, to be compared with the 25 arrests for the people who were offered the program and actually did participate. So what's the TOT?
So it's just the difference between those two? That would be 75 and 25?
Okay, which is minus 50 per, is it 100 this time?
50.
Yeah, we're only talking about people that participated, right? And the participation rate's only 50%. So it's minus 50 per 50, or minus 100 per 100, right? So the intent to treat was minus 50, right? We talked about that about 10 minutes ago. If you take minus 50 and divide by the participation rate, which is 1/2, you get minus 100 per 100. You want to have a per 100 in both cases. So the ITT the causal impact of this program is minus 50 arrests per 100 people offered the program. And the TOT, or the local average treatment effect, is minus 100 arrests per 100 people participating in the program. Right, it's the difference arrests between the people who did participate in the program and the people who would have participated in the program had they had a chance to participate. And because of the equation through random assignment of these two blocks of 125 crimes among the people who didn't participate, 125 arrests among the people who would not have participated had they had a chance. Those are going to be the same in both groups because of random assignment. So what's left has got to be the impact of the program on the people who took it up. These are non-participants. These are participants who took it up. These are would-be participants who would have taken it up had they had a chance. And that difference is 50 arrests. And we want to have the common denominator of per 100 for both. So before the ITT was 50 arrests minus 50 arrests per 100 people offered the program. Here, the treatment on the treated is minus 100 arrests per 100 people participating in the program. All right, questions?
I have a question, Greg.
Sure.
Kind of from a little bit of a like more global perspective. I don't know. Okay, so this is leading up to understanding how we do regression discontinuity, right? Like comparing right below and right above between the ITT and the TOT.
Plus a lot more. So, you know, this is this distinction between ITT and TOT pervades all the quasi-experimental literature in trying to estimate impacts of some program. So it's part of regression discontinuity, it's part of difference in difference, it's part of fixed effects, it's part of random assignment, straight up random assignment experiments. So it's, you know, we avoided this when we talked about estimating impacts of a regression for, you know, 100 individuals scoring 100 versus 110. We didn't even talk about take-up when we did that regression example. So we kind of avoided this problem of not universal take-up. You know, if it's universal take-up, then the ITT and the TOT are going to be exactly the same. But you know, for something like double dose algebra, right, which we'll be talking about soon, for something like the pre-K programs that Wong et al. Analyze, they're coming up with TOT treatments, the differences. These are differences for kids who are who just made the cutoff and almost all of whom participated versus those who didn't make the cutoff, almost none of whom participated. So this is kind of a global detour, and I apologize for it because it took a long time, and but it's important because this language of ITT and TOT comes up in all the literature, and it is very important because the first Head Start impact report only provided ITT estimates. In other words, the people who were offered a chance on the wait list to participate in the program in that particular Head Start center. And you got a set of impacts on reading and math and all sorts of outcomes that they measured. But it turned out that the net participation rate was only about 60%. You had these crossovers. You had people who were offered and didn't participate. You had people who weren't offered and did participate. So the effective difference was only 60%, not 100% in terms of participation rates. So what that means is that if you really want to know the effect of Head Start, as opposed to the offer of a slot in a Head Start program, you've got to take all those ITT estimates and divide by 0.6. You almost double them, right? So, all of a sudden, the program starts to look more important because for the kids who actually participated in Head Start, you were getting estimated impacts that were almost twice as big as what the report was claiming the impacts of Head Start to be.
Mm-hmm.
So that's quite a conceptual problem because, if you just kind of don't know this distinction and kind of casually read about the impacts, you don't realize it's of the offer and participation wasn't universal.
Yeah, okay. Yeah, that makes this make a lot more sense when you explain those little details of like why we're thinking about this in the first place. Thank you.
Okay. And sometimes you'll see arguments between people, some of whom are arguing on the basis of ITT evidence and some are arguing on the basis of TOT evidence. And the ITT numbers are always smaller than the TOT numbers, and they can't figure out which is right. They're both right in the sense that one is ITT and one is TOT, but they're linked by this very simple kind of formula. I should say ITT, if you have a program that you want to roll out, you can't control who participates in the program. You can control who's offered the program, right? So let's say you've got this wonderful vaccination program. What's the impact of the vaccination program on the population? One hopes that by late spring or early summer, 100% of the U.S. population will have had a chance to participate to get the vaccine. If then you track coronavirus cases and want to know what the success of the program was, right? There are two ways to think about that. One is of this massive program that was trying to vaccinate everybody, how successful were you in offering a chance to get a vaccine to everybody in terms of total number of coronavirus cases? That's one number. A higher or another number that shows higher effects presumably are going to be of the people who actually got vaccinated. What's the infection rate? So, two different things, and what policy can usually control is just the offer. So you really want to know at one stage, if you roll this out, make the offer, some people participate and some people don't, what's going to be the net effect of this rolling out the offer on the population? That's the ITT, right? And then if you really want to know, if somehow you could increase the participation rate from its 50% level to 100%, what would be the impact of the program then? And that would be TOT, right? Of the people who took up the program, what was the impact? So both are important for answering different kinds of policy questions.
Greg, I had a question. In practice, a lot of interventions will see attrition, so you will not have all the outcome data for whether it be treatment or control participants. Are you still able to do ITT and TOT under those circumstances?
That's a great question. You know, we're in this baby's first years experiment that I've talked about. You know, there's always attrition in surveys. There are, you know, attrition is never a good thing, and the more of it, the worse a thing it is. One thing people do to adjust for attrition is to try to look to see whether different groups had differential attrition. So let's say it's a population survey, and low-income families have an 80% response rate, and high-income families have a 90% response rate. One thing you can do is develop a set of weights for every case, which would effectively weight up the low-income families to account for their higher rate of attrition, and you're weighting down the high-income cases to account for their higher rate of attrition. You know, that assumes that you know, and again, it's the same kind of selection bias problem. If you know exactly why people aren't participating, why they attrit from a survey, and you've, let's say, you know, you start out, do a baseline survey, and then try to follow up a year later, you've got all the information in the baseline survey to try to explain who drops out and can't be found a year later, right? And if all the information that you have totally nails the characteristics of the people who didn't participate a year later versus those who did, then you can use this kind of weighting adjustment to weight up the groups with more attrition, and you're fine. But you don't really know whether you're able to completely explain attrition with baseline variables, and to the extent that it's related to unmeasurable factors, then you're in trouble, right? Because there's nothing you can really do to make any sort of adjustments, because you really can't, you haven't measured the kind of things that are most important. So, you know, number one in running a research project is to try to retain as many of those research subjects as possible, or as many of the survey respondents as possible. Otherwise, you're faced with some unpleasant kind of analysis choices, and you never can be sure that you've nailed down who and why people didn't. Well, you know who didn't participate, but you really don't know why.
Thank you.
All right. Any other comments?
Yeah, I have more question. So to get the effect of people participating in that, wouldn't it make more sense to find the difference between people who have been offered and like try to find the difference between the one who accepted the offer and the one who didn't? So like we have 100 people that were offered, and there were 50 that committed 125 crimes that declined the offer and didn't participate, and we have 25 from the ones who accepted the offer and participated. So if we try to find the difference between them, we just even have just controlled for the fact that they were offered in the first place. So this is what I'm struggling with.
Yeah, but you need a counterfactual. right? So the people who just of the people offered the program, right? 50 participated, 50 didn't. You don't know what went on in the minds of the people or the circumstances of the people who ended up not participating in the program, right? So you've got no way to make a sharp comparison of the 125 crimes that were committed by the non-participants versus the 25 that were committed by the people who did participate. So what's key here is you want to be able to compare each group to the counterfactual in the control group. And that's what we did. So there's no way, I mean, suppose you've got the 125 and 25. How does that give you a causal estimate of anything?
So, so because like in my mind, I'm just like trying to control for the fact that students were offered. So from those 100 that were under treatment, all have been offered the program. So, and some of them were offered and participated, and some of them were offered and didn't participate. So,
Right.
yeah, so for me, this is like two different control and treatment. So if the treatment is participating, one of them is a treatment group. That means that they participated, and one of them is like
participation is not randomly assigned, right? It's completely up to the individual actions of the people in the two groups. That's the problem, right? What's nice about random assignment is that on average, you've got a perfect balance in the conditions and characteristics and so forth between the two groups. So what you need to do is find for the non-participants in the 125 arrests, the counterpart in the control group, the people who, if they'd had a chance to participate, wouldn't have participated. And the trick here is that given the balance, you know that the people who would have not participated had they had a chance are like the ones who were given the chance and didn't participate. So the 125 is balanced between the two, and you just get the 25 and 50 or 75 by subtraction from the total. So that's the way
yeah.
that
Yeah.
works.
Got it. Thanks.